Hey there, welcome back. So today we'll be graphing our rational function f of x equal to 1 over x squared, and then we'll use transformations to see what happens there. So we can quickly sketch a graph out. Okay, so at first let me pretend like I have no ideas about the properties of this rational function. So let me just go about this the way I normally would. If I'm asked to graph this, I would try to look for an x-intercept, a y-intercept, those sort of things first. So let me look for that. So if I'm looking for my y-intercept, remember that's when my x's are equal to 0. So if I do that, then let me see, y over 0 squared up. I can't have that. I have a 0 as my denominator, which is undefined. So this lets me know that there is no y-intercept here. So I know that if I graph this, this will never cross the y-axis. Now, okay, well, at least let me look for an x-intercept. So that's when my y's are equal to 0. So if I do that, I'll get that 0 is equal to 1 over x squared. If I then try to solve for x, I get this. I'll multiply by x squared on both sides, and I get this times 0 is equal to 0, and this is left as 1. And this says that 0 is equal to 1, which we know is not true. Therefore, that means that there's also no x-intercept. So we have a situation here where if we start to graph this, this will never cross the x-axis, and it will never cross the y-axis. So you know what? Let me take it back even more old school and make a table. Let's pick some points and see what's happening with our graph. Okay, so here I just have a 3-column table where I chose some numbers to go ahead and substitute into my equation, so I can go ahead and see what the coordinates would be. So first one I chose is -3. I know there's better ones to choose if you already know what this kind of looks like, but like I said, I'm pretending like I don't know. These are the ones I chose. So if I choose -3, okay, my substitution in here would be 1 over -3 squared. This is 9, so 1 over 9. This would be 1 over -2 squared, 1 over 4. 1 over -1 squared, I get 1 over 1, which is 1. 0, we said was undefined, right? Because I get 1 over 0. So we know that something's happening in there, so undefined. And now I'm in my positive, so 1 over 1 squared is 1. And the last one, 1 over 2 squared is a fourth. So you can see that using my coordinates here, this looks like it's reflected about the y-axis, right? Everything starts to repeat for my y-coordinates. So you know what? I'm going to put these points up here, and then I'm going to choose some extra x's so we can get a better sketch of the graph.
So -3 and 1/9. Right here, -2 fourth, 2 fourth. -1, 1, -1. 1. 0 is defined.
Okay, so here are the points that we found earlier. I did add +3 here because I know that it reflects over, right? But I added these so we can get a better look at and understanding as to what's happening. I chose 10 just so that it's more spread out this way, but something weird is happening here towards the y-axis. So I chose also numbers 1/2 and 1/10 so that we can get a better feel for what's happening. So first let's do 10. Let's substitute that in there. So it's 1 over 10 squared, and I get 1/100th, right? So it looks like the bigger the x that I choose, the smaller the number I'm getting here. This is 1/100th, right? This is like having 1 penny. So this, if I get to the number 10, will be really, really small, right? So same thing here, because we know it's symmetric about the y, -10 would be really, really small. So this looks like it's curving downward, and same thing here, curving downward. But let's see what's happening closer to that y-axis. I'm going to go ahead and substitute a half in there, so I get 1/2 squared. You know what, I'm going to simplify it here so that we can do it together. So this becomes 1/1/4. Okay, so I squared the numerator. 1 squared is 1. Squared the denominator. 2 squared is 4. 1/1/4 is 4. Okay. Okay, so let's put in 1/1/10 squared. So same thing, I'll work it out here. So I get 1/1/100. 1 divided by 1/100 is 100. So my points are 10 1/100ths. So we saw that. Let me at least make it red. So 1/100th, it's all the way out there. But here, when my x is half, it becomes 4. Oh, that's already like outside of what I thought I was going to get. So I know that half is somewhere here, right? And remember, I kind of cheated, because by putting one number in, I know I get 2 coordinates because it's symmetric. So I also get the same answer for -1/2. And same thing for this one. When I put in 1/10, which we know is really small, is right around here. When I put that x in, I get a huge number. I get 100. So I know that this number here is huge, huge, huge. It's all the way over here. I'm not gonna write on my wall, but what's happening here is that your graph actually does this, okay? And on the right side, it does this. Okay. Let me show you with a nicer version on Desmos. Since I have Desmos already open, I just kind of wanted to remind you that this was your first rational polynomial that you graphed. Okay, so you've done this one before, 1/x, and this is what it looks like. And there again, we had these lines that didn't cross. But here we have it, 1/x squared. So let's do that. 1/x squared. Hey, that looks like what we graphed, right? Notice that here, and I'll zoom in so you can see better, your graph will not cross, does not have an x-intercept. So even though it looks like it's touching it, the more you zoom in, the more you'll see that, hey, my graph is not touching the x-axis. It actually never will. Same thing for my y-axis. I can keep going, and the more that I scroll up, it'll look like it's touching the y-axis, but it does not. It will not cross it, no matter what. And I can even pull up a table here, so you can see, hey, that looks like the table we created, right? Where this is undefined, it's not going to cross it, and we have some good points here for from our sketch. Okay. Now let's look at how we can use the transformations to sketch ones that are slightly more complex. Okay, wait, I know I said that we were going to move on to transformations, but 1 second, because you know I like to give you those good notes. So I thought it would be a good idea to look at the domain and range and see what's happening here. Because of all the things that are happening now, you can be asked a couple different things. So here I'm looking at as x approaches negative infinity, so remember that's relatively speaking, so from the origin over to the left side, you're looking at it backwards. So as x approaches negative infinity, my y approaches what? Okay, so as x goes negative, notice that my y's are going down, 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 and what are they getting to, but never touch? In that case, my y approaches 0, the value of 0 for the y's, okay? Now, what happens when x approaches 0? So we're going back to normal from left to right. So as x approaches 0, okay, so I'm coming here. I want to see what's happening when my x is coming this way. What's happening to my y is my y is getting huge, 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 huge. It's actually approaching infinity. So as my x approaches 0, my y's are getting gigantic, and there's no stopping them, and they approach infinity, positive infinity, okay? Depending on your course, I don't know how deep they're going into it, they might ask you as x is approaching 0 from the left side, so you look at it from what's happening on the left side, or what is it doing from the right side. So depending on what your teacher wants, how deep they're getting into the domain and range, then you might have different answers for that. Okay, but let's keep going. So what happens when my x approaches infinity? Okay, so this is positive infinity. You might see it with a little plus sometimes. So as x approaches positive infinity, so I'm looking at it this way, what's happening to my y's? Well, my y's are going down, 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 and they're getting closer and closer to y being equal to 0. They won't cross it. Remember, there's no intercept there, but they're getting close to 0. Okay, and that'll help us out for our next ones anyways. Okay, so now, finally, let's go ahead and see how to graph this with transformations. Okay, so here we're asked to graph something a little bit more complex. So we're asked to graph r of x equals 1 over x minus 2 squared plus 1. So this one I could actually take advantage of my parent function. I can graph this one using transformations instead of choosing points, then try to make a general sketch of it and connecting all the points together. So let's use our transformations to make a graph of this, okay? So taking advantage of 1 over x squared, I already know that it looks like this, right? I'm not going to cross the x-axis, and I'm not going to cross the y-axis either. Those are my asymptotes. I will never, never reach it. But I do know that I have 2 points that I'm going to use to work with. I have the points -1, 1 and 1, 1. Knowing those 2 points, those are going to be the ones that I'll use to shift my whole graph. So the first thing we're going to look at is what's happening to my x's, right? So here in this case, I am shifting either left or right. Do you remember the same rules apply as you've known before? Which way am I shifting in this case, left or right? If you chose right, then you're correct. Okay, remember the x's were usually the tricky ones because you see that minus sign there, you might be inclined to think, oh, well, it's going to the left. Be careful, it's not. You're going to the right. How many units? 2. So my 2 coordinates will move 2 to the right. So let's see. So right now, I'm affecting my x coordinates. So I'll move 2 to the right, 1, 2. So this one lands here where this one was. So this is now at 1, 1. But this 1, 2 is now at 3, 1. It's at 3, 1. So the other thing that happened, right? So I'm about to draw this over, but I want to mention the other thing that happened is my asymptote moved as well. Notice that before I could not cross that y-axis, but now since everything moved, that moves as well. My asymptote is now right around here. okay, which is, before it was at 0, where x equal to 0, now it's where x is equal to 2, because it was also shifted 2 to the right. So my asymptote is where my x's are equal to 2, but my y equal to 0, my x-axis stayed exactly the same. So we're going to say my other asymptote is still the same, where y is equal to 0. So right now I have a graph that looks like this. I know it's not the cleanest thing in the world, but I'll show you a cleaner version on Desmos, okay? So that's all I've done for right now, shifted 2 to the right, but I have something else that happened. I need to move either up or down. What about your y's? Am I going to move up or down? This one, because I'm adding 1, I'm going to go up 1. Okay, so remember, for your y's, it's whatever's happening there. So this 2 points will get shifted up how many times? 1 unit up. So I only care about my y points right now. So instead of 3, 1, it becomes 3, 2. And this becomes 1. Well, let me put it, I'll put it here. 1, 2. So now what I have is, well, wait a minute. I hadn't, my x-intercept, I'm sorry, my x-axis used to be my asymptote, but now that I've gone up, that also shifts up as well. So look what happens here. This time my x equal to 2, this is still my asymptote for my last shift, but this one here has gone up 1. It's gone up to here. So finally, my red one, my last transformation, looks like this. Okay, so I moved 2 to the right and 1 up, and I've made that graph. So when you're graphing, normally you don't have to make every single one like I did. You can just directly go from the parent to whatever your last transformation is. Okay, so let's look at a cleaner version on Desmos. So here we are. I wanted to show you the parent function first. So here I've made f of x equal to 1 over x squared, and we can see that we have our nice points. We have -1, 1, and 1, 1. So those were the points that we used as a reference to see what was going on with our transformation, right? And here I made r of x. Now I know it looks kind of crazy there, but all I did was I put in as variables, I put in an a instead of 2 and b instead of 1, so that I can slide them along here so we can get a better visual as to what's happening. So right now my a is 0 and my b is 0, so that's why f of x and r of x right now are exactly the same. But right now, let's see what happens when we start to change just a, right? One step at a time. So remember, a will affect if I am going to shift left or if I'm going to shift right. So we had x minus 2 in our problem. So let me change that to 2, and notice that, hey, okay, so just as we predicted, it made a shift to the right, and we're able to see that. And look, there's our 1, 1 for that left side that we graphed, and here is 3, 1 like we showed. Okay, notice that here my table changed as well. Let's put it, and notice that where it has a 2, right, it's undefined because that is my asymptote that shifted as well. This is my vertical asymptote that made a shift to the right. And let's see what happens when I change my b now. So remember, we said that the b should move up 1 when I change the b to a 1. So let's see if that's true. And yeah, okay, so look at that, holy moly, whack-a-mole. Okay, so my vertical asymptote stayed the same, but since everything shifted up, so did my asymptote. So instead of having an asymptote of the x-axis, it's gone up 1, and my asymptote here is where my y's are equal to 1. So this will never, 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 never go below positive 1. No matter how much I zoomed out, and I know I've shown you that before. So there, I wanted to show you the nice shift here in Desmos. All right, go ahead and try to graph this one using transformations. And I'll show you the answer in Desmos in 3, 2, 1. Okay, so remember, we always start off with our parent function first, and this point I know, so let me see if I can get to that coordinate before I even show this graph, right? So using the point -1, 1, according to this, I should be doing a shift to either the left or the right, and even though it says +1, I know I'm not going to let it trick me. I know that I need to go to the left 1. So from here, from -1, 1, I need to go to the left 1. Now, notice that we wrote -4 in front of our ratio instead of the end. Does it matter? No. Remember, we have the commutative property of addition, which says that it doesn't matter if I put this on the left or I put it on the right. I can change the order of the addends. So writing it like this is the same as writing -4 on the right side. So this lets me know that I need to go down 4 units. So from right here, so I already did my shift to left 1, and I go down 4 units. So count with me, 1, 2, 3, 4. This puts my new coordinate at -2, -3. Okay, so I should see this shift all the way down here. Let me turn on this graph, see if that's true. And yeah, so I have -2, -3. Okay, so I did my shift there correctly. Now don't forget what happens to that asymptote. Okay, before that it was here on the y-axis, it's now your vertical asymptote is where x is equal to -1, and your horizontal asymptote shifted down 4 spots. So your horizontal asymptote is where y is equal to -4. It will never go below this. Okay. Well, looks like that's it for today's lesson. So just keep practicing your transformations. You'll get used to them. You'll notice that you'll be able to graph a lot faster once you have those rules memorized. Okay. So until next time.